In this example, we're finding the derivative of x to the 1/2 minus 2 times x plus 4. We're going to use the product rule for this example. So product rule is derivative of the first times the original second. So if I call this my f of x function and this my g of x function, it's going to be derivative of the first times the original second plus the original first, and I said original while I wrote down derivative, the original f of x times the derivative of the second. Every time you do product rule, you want to just write down the rule, and this is something that you're gonna want to have pretty familiarity with. You want to get comfortable with it because that's going to make the rest of calculus as you're going through the calc sequence a little bit more simpler, like just to not have to worry about messing up the derivative of something like this. So derivative of the first, original second, plus original first, derivative of the second. So let's go ahead and do that. So let's take the derivative of f of x. That is going to be 1/2 times x, which is going to be 1/2. And then 1/2 minus 1 is going to be negative 1/2. 1/2 minus 1, negative 1/2. I'm going to rewrite that at the end. And then this is times the original second. So that's going to be x plus 4. And you probably don't want to rewrite it right away just because we are going to have to distribute this. So that's why I was going to hold off until the end, but I think something might happen here when we distribute. Plus the original first, so x to the 1/2 minus 2 times the derivative of the second. So the derivative of x plus 4 is just 1 because the derivative of x is 1. 4 is a constant, so just 1. All right, not too bad. So now let's go ahead and distribute the 1/2 x to the negative 1/2 times x and times 4. So 1/2 times x to the negative 1/2 times x. This is x to the first, so this is going to be 1/2 because the coefficient here is 1. 1/2 times 1 is 1/2 x, and then I have negative 1/2 plus 1 because I'm multiplying by the same base, and when you're multiplying by the same base, you want to add the exponents. So you're going to do negative 1/2 plus 1. So this is over 2. 2. Negative 1 plus 2 is a positive 1 over 2. Nice. It works out pretty nicely there. And then we have 1/2 x to the negative 1/2 times 4. 4 times 1/2, almost said 4 to the 1/2. 4 times 1/2 is going to be 2. 4 divided by 2 is 2. And I don't have any x there, so x to the negative 1/2. Plus, and then x to the 1/2 minus 2 times 1 is just going to be x to the 1/2 minus 2. Okay, I think we have some like terms here because I have x to the 1/2 and x to the 1/2. So those are going to be like terms, so let's go ahead and combine those together. So we're going to have 1/2 plus 1, 1/2 plus 1 over 2, 2, 3/2. So 3/2 x to the 1/2. So I combined this and this. And then I have this 2x to the negative 1/2. I do not have any terms with x to the negative 1/2. And just to save myself a little bit of some time here, I'm going to rewrite this, bringing this down to the bottom. So this is going to be plus 2 over x to the 1/2, like that, minus 2. So that minus 2 there, because I don't have any other constants. So this would be my derivative of that. You could rewrite this 3/2 square root of x plus 2 over square root of x minus 2, but this is fine also. And that's about all we can do there. So that is the derivative using the product rule. And you could have also expand this out, x to the 1/2 times x, x to the 1/2 times 4, and then did this and this, pen drag there. So that's another option, but just practice using the product rule.